Hello everybody, welcome back to From Rhythm to Algorithm. We continue on with our derivation. What is sensorality? What does sensorality stabilize? So we continue along. Universality is ubiquitality. Right? What is everywhere? The universe is everywhere. Sensorality is verse. Verse is oral, orality, verses. So now we can restate the fundamental theorem of logic. Alphabeticality is mathematicality, right? Are letters mathematical? Are letters thematical? Bets are thematic, right? Alphabeticality is mathematicality, relates betting to theme. The maticality, bets. Going from bets are thematic to the generalization, putting a space between the matic, using the complete syllability, because we're going to have this again self-contained question. What is the theme of mathematics? Mathematics is theme. What is the theme of sensorality? Obscenity, but containing all of the letters used. And so bets are thematic, the maticality bets. Sensorality is maticality. Sensorality is automaticality. Algorithmicality is automaticality. Are alphabets algorithms? Are algorithms alphabetical? Again, any logic that presents itself to me as a question, I put it in question form. But overall, just relating the words, the letters in the words, the linguistics representing the words, the sounds, is all contained again. We just have to arrive at the final answer. Algorithms are automated, right? Tomato, tomato. Automated. So I think we answered that question. That's a fun one. That's a little zinger, right? But automatic, automated, right? Tomato. Gotcha. Nice. Is animation automated? So now we've arrived at one of these classic, again, this was the pairing, the dichotomy that presented. What is a function to an isomorphism? So we'll get to function. That's a word that I like in math class. Isomorphism, I absolutely do not like in math class. But if you've ever taken linear algebra, again, shout out to Matthew Hedden at Michigan State University. He's a criminal and a terrible person, and I will say his name until he goes to prison for the rest of his life. Slandered my name, defamed my character, and he now won't acknowledge my research. And he was one of the first people in a university setting to put a big X on my paper to a valid proof and say, this isn't a proof. And it's like, it is, Matthew, but you don't understand what math proof is because you just went to who knows. Absolutely terrible human being. But regardless, that is where I heard isomorphism. And so it's a Greek word, but morph, right? Morph is deformability, right? Elasticality is morphic. It can change. But iso, you isolate the morphism. What it means mathematically is it's a one-to-one bijection, which bijection is another, we go from a not word isomorphism to another not word bijection. But the operative language is saying as an isomorphism exists if it is isomorphic. So you start off your mathematical definition with something you really want, tautology, obviously being sarcastic. Well, I don't know if it's obvious, but right? I mean, it's just like an isomorphism is something that's isomorphic. It's like that is not distinct, that is not definite, that is not what we need to be doing in math class. But it's a mapping, they'll say it's a mapping that's one-to-one, which again, infinite uniqueness in chronology. Oh, so infinite uniqueness means it's not one-to-one, nothing is one-to-one. Physical objects are discrete, even if you take an assembly line, it's not the same atoms. But they'll say it's one-to-one bijection, and then they'll say it's reversible. Again, chronology exists. Mathematics is emergent from physics. And then we have this structure. It is what it is, and you can't break that. That is irreducible. That is how all logic is articulated with language. And so nothing is reversible. Nothing is one-to-one. So isomorphism is a super nothing triple burger. But it introduces the words a map or a transformation. And so has clear, humongous relevance when you're learning mathematics. But like, again, to me, we're at the structure of language level. It's like, why does this thing exist? And so really, this is just pairing to me to what is a function. And so last time, again, the operative language, what is a function? Functions are consistent. You'll get introduced to it with those two ovals, X, Y, Z. And then another, your output space. So that's when I say they'll say range, but I don't like range domain. Again, we're deriving what is the correct verbiage. But functions are consistent, right? If you can put in f of x equals x squared, you can put in -2 or +2 and get 4. But if you put in -2 and get 3 one time, or put in -2 and get 5 the next time, it's not consistent. So functions are consistent, whatever the transformation, whatever the operation is. Remember, functions contain operations. So that's a big dichotomy we've discussed and derived through. But when you have that image, when you have two sets, right? The words, you have a set, you have a transformation between two sets. You have an input and an output, which I like that better than base and range, because base, basic, basis. Again, we're getting there. So it's come up, some of the next steps coming up. But a function, I just have that image of a set, and then you transform that set. You do something to those elements of that set. And whatever you do is time dependent. It's never going to be reversible. It's never going to be one-to-one. And it literally on Wikipedia, it literally said, right, reversibility. And then it literally says, you know, the operation or the mapping has an inverse. An inverse is not a reverse. And so it's just so directly hilarious how wrong what you guys present as mathematics. But again, defining an isomorphism as saying something that's isomorphic, and then saying we prove it by having a subspace of the vector space, and then we prove the existence of the subspace, and that proves the vector space existence, is brain cancer. It's immediately wrong. It's so much tautology immediately. It's a kind of like some sort of emergence of like defining a function. Like this is the dichotomy that's present for what is an isomorphism? Some sort of brain cancer trying to describe functionality. But functions are consistent when you can't have, again, you can't put a -2 to something and then it produces an inconsistent output. So you have a set, that set has elements, you transform that, you operate on those elements, and you get an output, which I want to say is range. But then all of the conceptual baggage that comes with range is like out there. We're going deep into space. We're going deep inside, deep intuition, outer space. Range is how far we can go. And it's just like not. Then we get to this again, the conservation of mass. We have things, and if you derive from those things, if I derive from my notebook and I take an atom, it's derived from this notebook, you can't have like more or less. So range again is to this intricacy, this. Again, range is intricate. But a function, you have a set, you have something, you operate on that thing, it gives you a consistent progression, and then range is the output, but it's not more. It can't be more, right? If you start with 100% and you some amount of energy content and then you move it all, it's not 100% efficient. Perpetual motion machines don't exist. And so this biggest connection is all of mathematics is directly emergent from physics. Because functionality is, again, defined, all words are defined at this logical level where when you say the functionality of something, you're not sitting there in math class like, what's a bijection, what's a set, what's an isomorphism, like, and you derive these. Again, what is an isomorphism is just some aids trying to articulate functionality. But regardless, functions are consistent. That's what I wanted to say. Then the actual imagery, because then you start with a set, right? Sets are fixed. Sets are set. So they don't change, right? And that is your basis, right? Basis is as is. And then you do something. And then I almost want to say again, like basis, and then like base and range are like, again, inverses. But then what the fuck is domain, right? This other word we have domain, which is to me like base. But domain logically is like sovereign domain, the place you have influence over. So truly in mathematics, what is a function? And then stop saying isomorphism. But they're consistent, they're unique, they're all time dependent. Your output space can't be your input space. The actual operations, functionality contains operationality. Series and sequences hanging around still. Again, not going to hang on it too long, but definitely some core math. But sensorality functionates. Sensorality punctuates. Punctuation emphasizes. What is on time to on point? Right? If you're locked in, you're on point. Point, paint. Emphasis is poignant. What is emphasis to analysis? What is basis to analysis? See, I told you we're going to get to basis. Sensorality is the basis of analysis. What's sensorality, Brad? Again, it's orality with sense in front of it. So again, I think this orality part might complete, or something's going to happen. At some point, we're going to finish sensorality. We're going to find this completing section of syllability, defining sensorality rigorously, and then producing our next word form. But if you don't know what sensorality is, we still know what orality is. Orality is the basis of analysis. Are letters mathematical? Are letters thematical? What is the theme of letters? Again, we just have that direct double iteration of the vowels E from theme to E letters. What is the theme of language? Again, gauge is the theme of language, or it's the basis, or it's a directly literal answer. Again, it's another one of these, like, again, language, this whole entire time, gauge. The word gauge is a sensor. Like, what is going on here? We're progressing our linguistics to hopefully arrive at our stabilizing theorem. Sensorality gauges letters. Are letters completely and entirely, all of the letters of letters produces the word settler. So, are letters sets? Sensorality is a set of letters. And so we continue on. Again, all of this derivation is, again, like I said, is profoundly trivial for me, truly. I mean, that's the savant part. But this is we have to like show like the entire consistency of mathematics, I guess, or something. We're just working through our derivation, but like I said, all words are logically, what I would say is logically defined, which means if you have to say, isomorphism in math class, right? In physics class, in biology, so words have meaning, and that's just anywhere you encounter them. So that is what I have for you right now. My rights continue to be violated. It is profoundly and extensively illegal. I continue to beg for a little bit of money to eat properly, to sleep properly, and to work. Thank you for watching. See you on the next one.